Variables in R can be of different types. For example, we need to distinguish numbers from character strings and tables from simple lists of numbers. The function class helps us determine the type of an object. For example, if I define A as 2 and I look at its class, I will see it's a numeric. Here's another example. Let's look at the class of the function ls. Not surprisingly, we see that it's a function. Up to now, the variables we have defined have been just one number. This is not very useful for storing data. The most common way of storing data sets in R is with data frames. Conceptually, we can think of data frames as tables. Rows represent observations, and different variables are represented by different columns. We're going to see an example soon. Data frames are particularly useful for data sets because we can combine different types into one single object. We store the data for a motivating example in a data frame. You can access this data set by loading the DS Labs library, and then after that, loading the murders data set. We do that using the function data. To see that this is in fact a data frame, we type class murders, and we see that R tells us that in fact it is a data frame. This is where the relevant data for answering our questions is stored. So we know our data is stored in the object murders. But what is this object? How can we find out more about this object? The function str is useful for this. Str stands for structure, and it shows us the structure of an object. If we type str murders, it shows us that, for example, it's a data frame. It has 51 observations, 51 rows, and 5 variables. On the left, we can see the variable names: state, ab, which is abbreviation, region, population, and total. So this all makes sense. We can see that this is going to all be useful for answering our questions. We can also show the first 6 lines of this data frame using the function head. We type head murders. We see Alabama, Alaska, Arizona, Arkansas, California, and Colorado, along with the variables associated with each state. This object follows the convention that we described. It's quite common in data science. Rows are the different observation, in this case states, and columns represent different variables. In this case, state, abbreviation, region, population, and total. Okay, now we want to start accessing data from this object. So before we go any further in answering our original question about different states, let's get to know the components of this object a little better. For our analysis, we will need to access the different variables represented by columns. To access these variables, we use the $ symbol. It's called the accessor. Here's an example. If I type murders and then $ population, it shows us the column associated with the population size. But how did we know to use the character population? Above, when we used str to reveal the structure of the object, we saw the names of the columns. We can also get the names of the columns using the names function. Names murders tells us the 5 names of the 5 columns. So we can see the population is one of those names. So we can use the accessor combined with those names to access any of the columns in the data frame. It is important to know, for the rest of the analysis we're going to do, that the order of the entries in the murders $ population list that we get, it preserves the order of the rows in our data table. As you will see, this will later permit us to manipulate one variable based on the results of another. For example, we might want to manipulate the state names by the number of murders. Note that the object murders $ population is not one number, it's 51. We call these types of objects vectors. A single number is technically a vector, but in general, they have several entries. The function length tells you how many. So if I define a new object called pop for population as the column in the murders data set that has the population sizes, and then I type length pop, I will see that it's a vector with 51 entries, 1 for each state. This particular vector is a numeric vector since population sizes are numbers. Now let's talk about character vectors. We can store characters in R as well. Because variables also use character strings. We're going to use quotes to distinguish between variable names and character strings. So if I type A and assign 1 to A, the variable A is 1. So if I type A in R, I get back a 1. However, if I want to now work with the character string A, I need to use quotes. So if I write quotes A, then I get back the character string A. An example of a character vector is the column with the state names. So if I grab that column by using the $, and I look at a class of that column, you will see that it's a character. As with numeric vectors, all entries in a character vector need to be a character. Logical vectors are another type of vector. We don't have those in this particular data frame, but we need to mention them. These must be either true or false. So we can create a logical vector by, for example, assigning 3 equal to 2 to the object z. When I type z, we see that it's false. That's because 3 is not equal to 2. And if we type class of z, it returns a logical. This is because equal is a relational operator, asking if 3 is equal to 2. Note that it's different from just 1 equal, which would assign 2 to 3, which would, of course, give us an error. There's one more data type we want to cover. It's factors. In the murders data set, we have a column called regions. These are the regions of the US, so which state is in which region. We would think that this would be a character because the regions are things like Northeast and South, etc. But when we look at the class of the regions column, we see something new. It says factor. So let's learn about factors as they appear often in R and in data science. Factors are useful for storing what is called categorical data. The regions are categorical. There's only 4 categories. Each state is in one of these 4. We can see the 4 levels in this particular factor using the function levels. So we type levels, murders, $region, we see Northeast, South, North Central, and West. So why do we do this? It turns out that saving categorical data this way is more memory efficient. So in R, in the background, we store integers. We store the levels as integers. Technically, integers are smaller memory-wise than characters. So this is what makes it more efficient. However, factors are also a source of confusion, as they can easily be confused with characters. If we just look at this variable, they would appear to be characters. It's only when we ask using class what type it is that we see they are factors. We will learn more about factors in later videos. In general, we recommend avoiding factors as much as possible, although, as we will learn later, they are sometimes necessary to fit statistical models that depend on categorical data.